All right, we're in section 10.6 where we're going to construct and interpret binomial distribution. So we have some terms uh, on this first page that we're going to take a look at. And basically, these terms are going to help us kind of deviate or kind of dive into whatever problems that we are going to encounter for this particular section. So the first one is talks about a random variable. It says random variable is a variable whose value is determined by the outcome of a random event. All right. Um, we have probability distribution. Probability distribution is a function that gives the probability of each of the possible outcomes for the random variable. We have binomial distribution, which is a type of probability distribution that shows the probability of the outcomes of a binomial experiment. That binomial experiment is where you have n independent trials where there's only two possible outcomes. For example, like success or failure. The probability of success value p is the same for each trial, so there's no like deviation from it. So usually it's like either yes or no, or true or false, or in this case, like they talked about with success and failure. These types of experiments can be displayed using a histogram. Uh, if they are divided into two parts, that is a mirrored image, it's said to be symmetrical. And if this distribution is not symmetrical, it's called a skewed distribution. Okay. So probability distributions, it states here, a probability distribution is a function that gives the probability of each possible outcome for a random variable. The sum of all the probabilities in a probability distribution must be equal to 1. So what we have here is we're letting x be a random variable that represents the sum when two four-sided dice are rolled. All right, so it says make a table and histogram showing the probability of the distribution of x. So what we have here is these are all the possible outcomes for rolling two four-sided dice. You can get a sum of 2, 3, 4, 5, 6, 7, or 8. Now what this is with the outcomes is um, the experiment and how many times it was that value. So you had one outcome for 2, 2 outcomes for 3, 3 outcomes for 4, 4 for 5, 3 for 6, 2 for 7, 1 for 8. So what that did was there were 16 trials, so the probability of you getting that was what we have here. So 1 out of 16 for 2 and 8, 2 out of 16 or 1 out of 8 for 3 and 7, 3 out of 16 for 4 and 6, and then 1/4 for 5. So what we did here is we created a histogram, which is it's a bar graph where there's no spaces in between the bars. And what we've concluded is that this particular histogram is symmetrical because you could cut it in half and it'd be a mirrored image. Okay, so well, what we can do now is we have some questions here that they're asking. It says, what is the most likely outcome of rolling two four-sided dice? All right, so this says the most likely outcome of rolling the two-sided dice is the value of x, which the probability is the greatest. So if we look up at the chart, the greatest chance was 1/4, and that was getting a sum of 5. So the most likely outcome is the sum of 5. Question they ask here, it says, what is the probability that the sum of two dice is at most 4? So basically what we're trying to figure out is you want to know the probability of getting sums of 2 uh, 3, and 4, because at most it says so it was less than or equal to. So in the basic you do is probability where you get a sum of 2 plus probability where you get a sum of 3 plus the probability of getting a sum of 4. So you just go up there and say, all right, it was for 2, it was 1 over 16 plus the sum of 3. We'll just keep it the same denominator. It was 2 out of 16 plus 4, that was 3 out of 16. So 1 plus 2 plus 3 is 6. So we got 6 out of 16, which gets reduced to 3/8. If we attach it as a percentage, it would be about 37.5%. All right. So binomial experiment. So a binomial experiment, it says it must meet the following conditions. It says there are n independent trials. So however many trials there are, you get to pick them. Uh, each trial has two possible outcomes, like they said, success or failure, or yes or no, or true or false, stuff like that. Probability of success is the same for each trial. The probability for success p um, and the probability of failure is 1 minus p. So whatever the success is p, whatever the failure is 1 minus p. So like if you flip a coin, you have a 50% chance of successing, but you also have a 50% chance of it failing. So the formula that we have right here is what is going to help us, where um, n is the number of trials right there, k is how many successes it has, and the p minus 1 talks about the failures. So we have um, down here, it says a survey taken in your school found 68% of students are not afraid to fly. Suppose you randomly surveyed 5 students and it wants you to draw a histogram of a binomial distribution for your survey. The probability that a randomly selected student is not afraid to fly is p equals 0.68 because it's 68%. Because you have 5 students in the survey, n is going to equal 5. So what we have here is all the different possibilities. This is where if you ask 0 people, if you talk to 1, talk to 2, talk to 3, talk to 4, talk to 5. Um, so what we're going to look at is this. If basically if you talk to 0 number of people, or if you had exactly um, 0. Oh, I'm sorry. So if you talk to 5 people and 0 people said that they were not afraid to fly, is that would be a 0.3% chance. It would be very unlikely if you came into 5 people and they said that it would be 0. Like all of them would be afraid to fly. For the k equals 1, that means that one person of the 5 said that they were not afraid to fly, which means 4 of them were. That would be a 3.6% chance. Um, two, two means that 2 of them said that they would not be afraid to fly. That would be a 15.2% chance. So now we're going to try to find the rest of them. So we're going to try to find the probability of 3 people said they're not afraid to fly, 4 people said they're not afraid to fly, and 5 people said they're not afraid to fly. So we're going to set this up. It's going to be a combination where we have 5 people and we're going to go 3, and it's going to be 0.68, and we're going to raise that to the third power, and then we're going to go 0.32, and we're going to raise that to the second power. So looking here, 5C3 is 10, so I got 10 times it by 0.68, raise that to the third power is 0.314432. That gets multiplied by 0.32 squared. So, and I multiply it by 10. So I'm just going to write in to the third, 0.32 squared. I get 0.3298, which is about 32.19%, we'll call it. All right. For the next one is if we find out that of the 5 people, 4 individuals said that we were not afraid to fly. So we got what, 0.68, raise that to the fourth power. We got 0.32, raise that to the first. That'll equal, so if I go 5C4, I get 5. So now I get 5 times it by 0.68 to the fourth power, 0.32 to the first. 0.68 to the fourth power is 0.2138 on my calculator. Times that by 5, times that by essentially 0.32. I get about 0.3421, which is about 34.21%. And then the final one is if the probability of all 5, you got 0.68, raise that to the fifth, 0.32, raise that to the 0. So this is essentially going to be 1 for that combination, and then we got 1 for the, so all we essentially have to do is figure out what 0.68 to the fifth power is, and that is about 0.1454, which is about 14.54%. Okay, so if we were to kind of draw a histogram for this, extend this a little bit. So make a graph, and we'll say 0, 1, 2, 3, 4, and 5. And then if you want to put the decimals or the percentages, whatever it may be, it's kind of up to you. So if I'm just going to say, we'll go 0.10, we'll go 0.20, 0.30, 0.40. So when it was 0, it was 0.3, so it was really small. So something kind of like that. When it was 1, it was 3.6, so it's even smaller than that. And then 2, 15, so somewhere right around here. We got 3, which was 32, so slightly above. And then with 4, it was 34, so it was even a little bit more before that. And then the 14, 4, 5. So here's our histogram with the results that were given. This particular histogram is going to be a skewed one because it's not a mirrored image. All right, so it says, what is the most likely outcome of the survey? So just by looking at the chart, we can say that the greatest probability in this case would be k equals 4. So that means that our most likely outcome is that 4 out of 5 students will say they're not afraid to fly. Here it asks, this is what is the probability that at least 3 students are not afraid to fly? So this would be, you find in the probability of finding 3 plus the probability of finding 4 plus the probability of finding 5. So if we go back up to the chart, probability of finding that 3 of them was like 0.322 plus the probability of finding 4, which would have been 0.34, what call it 342. I'll make that decimal a little lower. And then finally, probability of it being 5, which was 0.145. So add those up. I get a result of 0.809. So probability is about 80.9%. Is that right? Yeah. So really close to 81%. So there's an 81% chance of at least 3 students stating that they're not afraid to fly. Okay. And that is being able to construct and interpret a binomial distribution. Hope this helps. Until next time.